I will try my best. So today I'm going to talk about an agent-based model of sex ratio at birth distortions. And the outline of my talk will be, I will start with an introduction that I will like to show you the motivation of this project. Then I will briefly discuss what's agent-based modeling. I don't know which is, if you are all familiar with agent-based modeling, so I will try to explain a little bit what it is, the idea, so we are to make sure that we are all on the same page. Then I will give you the model description, some results, and conclusions. So what's the motivation underlying this project? So the main idea is that since the 70s and 80s, many Asian countries have experienced a decline in the total fertility rate. And this decline of the total fertility rate has been accompanied by an unprecedented increase of the sex ratios at birth. Sex ratios at birth measured as the number of male births divided by 100 of female births. And we have different patterns. For example, we have the case of South Korea, that it has a steep increase in the 80s, then a leveling off in the 90s, and then decline towards normalcy. Other countries like China and India are still experiencing this increase, or maybe a leveling off. And we have the case of Turkey, in which the decline of fertility didn't have any effect on the sex ratios at birth. And these distortions of sex ratio at birth cannot be attributed to natural causes. So everything suggests that there is some kind of prenatal sex selection or sex-selective abortion that is generating these unprecedented distortions. So the idea of our model is try to evaluate what and why this is happening. And so today I will explain, these are two papers I did together with Riddhi Kashyap, that some of you might know. She's at University of Oxford. And we try to build this model to analyze what's going on, why is this sex ratio at birth distortion happening. So, what's agent-based modeling? Yeah? If we borrow from the literature, what we have is that agent-based modeling is a class of computational models that implement theoretical rules of behavior, decision-making, interaction among autonomous agents. Autonomous agents can be individuals or groups of individuals, for instance, families or couples. And we put all these theoretical rules in a simulation, and in this simulation we try to explain the emergence of macro-level patterns, what we see at the macro level, and potentially account for their feedback in the agents again. So it's a simulation process that we have some agents, they interact, you have some macro-level patterns, and then we see how this affects the individuals again. This is why, so the idea is the interaction and macro-level patterns. And this is why we said that agent-based modeling adopt a bottom-up perspective, because we go from the micro, from the agents that interact, to the macro. Yeah? The first attempt of doing a dynamic model to analyze human behavior, that was probably, as far as I know, it was the segregation model by Schelling. And also, agent-based modeling has been used widely in economics, but there are a relatively low number of applications in demography. However, there are some prominent works that try to apply agent-based modeling for family formation, transition into parenthood, or migration. If we can establish like a starting point or a first time that agent-based modeling was introduced into demography, that will be probably the book edited by Francisco Villavicencio and Alexia Priskavec, agent-based computational demography. This book was the result of, there was a workshop in, I believe it was in the Max Planck Institute in Rostock. There was a workshop of several scholars gathered together, and they discussed what agent-based modeling what it is, what can contribute to demography, and they edited this book that has two parts. First is the theoretical part, what agent-based modeling is, how it can contribute, and then applications for a specific solving specific problems. That was in 2003, and then in 2017 there was a second book that attempted to be like a second edition of this initial workshop. It was also a workshop. It was this case in Leuven. And there was, again, so what did agent-based modeling contribute to demography during that time? What can we do? Which are the applications? So I would say that these were the two main contributions, or one of the two main contributions to agent-based modeling in demography. And why is agent-based modeling interesting in demography? Why are we interested in this? I would like to mention this idea by Francisco Villavicencio that we have a two-stage view of population dynamics. So in demography, we have like what will be the discovery of regularities at the macro level. So to do this, we can use formal demography or mathematical demography and other summary measures. And then we have a second stage in the analysis of population dynamics that will be the explanation of those discoveries at the micro level perspective. That means at the individual level. And then the advantage of agent-based modeling is that they can help bridging the gap between this micro and macro. So that's probably the most important thing that agent-based modeling can contribute to demography. Other things that are important or relevant about agent-based modeling is that usually there is an agreement among the scholars that ABM should focus on the explanation rather than prediction. When we build a model, what we want to do is to explain what has happened and why this has happened. We're not so worried on doing future projections or predictions. The second, another important issue is that agent-based modeling helps to analyze complex dynamics in which mathematical analysis struggles. For example, if we want to model mortality, we can use Gompert's model or Gompert's-Macon. This is a very nice equation that is very easy. But if we want to model complex dynamics among individuals that have different beliefs that interact among each other, here we cannot. It's very hard to have a mathematical expression to show this. So it's much better, or it can be more convenient to build a model, a dynamic model that can account for all these interactions. So, in turn, what ABM provides is more flexibility. It also helps to account for a population heterogeneity because we can have different individuals that are in, for example, different social status, different economic status, different regions, and this provides, we can include all these differences among individuals. And finally, it's very useful when we don't have empirical data available, when we are trying to analyze something, a specific phenomenon or a study that we don't have data or not accurate data, then we can build an agent-based modeling to analyze that. Okay, just final slide about agent-based modeling. There are some views that suggest that agent-based modeling is even a third way of doing science. This was Axelrod in the 90s. I had a question mark because I think it's probably a little bit optimistic because 20 years later it's hard to say that it's really a third way of doing science, although I agree with him that it's very powerful. And also the main idea that I like from him is that ABM can be used to add intuition. In the particular case of the demography, the Courgeot et al., Courgeot-Bijak et al. Also agree that I agree with them that it's a very powerful tool, and even suggest that if ABM can really become a standard tool for demographers, maybe in the near future we will be able to say that the implementation of ABM in demography can even represent a paradigm shift in the development of the discipline. Okay, so this is for the agent-based modeling, just an overview, so more or less you have an idea of what it is. And now I will go deep into our model, our particular model, and the problem we want to tackle. So basically, this is the same slide I showed you earlier. So we have this problem that we have a fertility decline and some sex ratio at birth distortions. And we want to, and we suggest, the idea is that there's somehow some prenatal sex selections, some abortion procedure behind that is generating this. We want to understand why is this happening and what's going on. So first, if you want to build an agent-based modeling, we need to borrow from the literature, so a theoretical framework. Because as I said previously, first we need to have some theoretical rules that we want to apply to our model. So according to the literature, Guillemotto suggests that there are 3 conditions for the practice of prenatal sex selection. First, we are in a context of family decline. So couples are willing to have smaller families. Second is that there is a persistence of some preference. And then we have these 2 elements. Smaller families, but still, because of cultural beliefs, couples still want to have a son. So in order to reconcile these 2 elements, then we have prenatal sex determination technology that emerges as an exogenous element that allows to reconcile these 2, declining family size and some preference. In a more wide perspective, a more general framework, there is this ready, willing, enable framework that was developed by Ansley Cole to explain the decline of fertility in Europe in the 19th century. And Guillemotto also suggests to connect these 3 elements to the ready, willing, enable framework. So we have that there is a readiness to practice sex selection because of the fertility decline, willingness because of the son preference, that couples still want to have at least one son, and then we have the ability, that is the access to technology. When you have access to technology, you can practice this sex selective abortion. Sorry. So, why is in this case useful to use an agent-based modeling? Well, because, as I said, you have all this flexibility that provides a dynamic model, so we can try to, in our model, try to evaluate which is the trends or the levels of this some preference, technology diffusion, and sex-selective abortion have on the observed SRB trajectories. Second, because thanks to this flexibility, we also can have some counterfactual scenarios. For example, we can say, okay, we can try to analyze what will happen, what would have been the fertility levels without abortions. So we can evaluate which has been the effect of abortions in the decline of fertility, because of course if there are abortions, this will have an effect of decline of the fertility will decline faster. And also, even though I previously said that agent-based modeling should focus more on explanation rather than prediction, it can also use these models to have some projections and try to have an idea of which will be the future trends of SRB trajectories. So let's go focus on the model, on this particular model that we are building. So we have one main goal. The main goal is to model the emergence of these distorted sex ratios at birth from 1980 onward. And we did it for 2 countries, for South Korea and India. The reason of doing this for South Korea is that South Korea already had this sex ratio transition, that is steep increase, leveling off, and going back to normalcy. And India is in a previous stage. So we are building is what has been usually called a semi-artificial population model, because it is adapted to use empirical data. In particular, we use the fertility and mortality rates from the United Nations. There are 2 basic procedures in the model: aging and reproduction. And this reproduction includes conception, abortion, when is the case, and birth. And we implemented everything in R. So here, now you can see how does the model work, what is the model doing at every time step, and how we are formalizing this ready, willing, and able framework in a model. So we start with this question: does the agent want a son? If the agent doesn't want a son, because it doesn't have a son preference, then she will be subject to standard age-specific fertility rates. If the agent wants a son, then we have the first condition, which is willingness of having a son. Then the next question is, does the agent has access to technology? If the agent doesn't have access to technology, but is willing to have a son, then she will be exposed to higher age-specific fertility rates until bearing a son accomplish their desire. If the individual has access to technology, then second condition is met, able. Then the question is, does the agent conceive a girl? If yes, does the agent want to keep family sizes small? That's the last question. Because of the fertility decline, she wants to have a family size small. If no, then higher age-specific fertility rates until bearing a son. If yes, then the individual has met the third condition and then is ready to abort. So this is more or less how the model, schema of how the model works at each time step of the model. We are always asking the model to each individual all these questions, and if everything, all the conditions are met, then the individual will abort with certain probability. So now this is the picture. Now the math. Okay, don't be scared. Only 3 slides with equations, and that's it. So first, this sum preference. So the sum preference, we model it by modifying the age-specific fertility risk of one individual. So we start with this H star is the standard specific fertility risk. This is what we get from UN data. And then, if an individual SP stands for sum preference. If the sum preference is 0, so no sum preference, this individual, then this individual will be subject to standard age-specific fertility risk. This is from the previous slide. We are in this case. The individual doesn't have a son, doesn't want a son, doesn't care, then standard age-specific fertility risk. This is what I'm saying. We are saying this equation. If the individual SO stands for number of sons, if the current number of sons is smaller than the sum preference, for example, the individual wants to have at least 1 son and has currently, in the current time step, only has 0 sons, then this standard age-specific fertility risk will be increased by a gamma factor. For example, if gamma is 0.05, this means that it will increase by 5%. And then once, the third scenario is that if the individual has a sum preference, so this sum preference is different than 0, and the current number of sons is higher than the sum preference, let's say the individual has a sum preference of 1 son and then currently has 2 sons, then what we did is that her fertility risk will decrease by alpha parameter. Okay? So at the end we have standard. This gamma parameter is kind of captures the son preference intensity, and then alpha is a parameter that is adjusting the son preference when adjusting the fertility risk when the son preference has been met. So this is the first element. Then the second one, ability. For the ability, very simple. We did a logistic diffusion model. Depends on time, the rate of the diffusion, and the inflection point. So this is very standard way. What we're saying is, okay, at the beginning, very few people have access to technology, then this access increase, and at the end, almost 100% of the population has access to technology. You will see some plots later to visualize this. And finally, the fertility decline, the readiness. The readiness is when is the last, if you remember the graph, is the last very final step, is when you decide if the individual will abort or not. So we have to meet 2 conditions. First, that the sum preference is higher than the number of sons. So, for example, sum preference of 1, and still the individual only has 0 sons. And the individual has access to technology, then we assign the probability of aborting this way. We have 2 cases. First case is that the current parity is 0, so the individual has no children. In this case, the probability to abort will be the minimum between 1 and this quotient, between a beta parameter and the total fertility rate obtained from the simulation. If the parity is higher, so the individual at least has 1 child, can be a girl usually, then the probability will be the minimum between 1 and the current parity multiplied by this sigma parameter divided by the total fertility rate. So what is this telling us? What are the important things here? First, why are we doing this minimum? We're doing this minimum because we want probabilities. So we want a value that is between 0 and 1, and this quotient can be higher than 1. So this is what is a maximum of 1. Second, we have to distinguish between parity 0, that means having aborting before even having one child, and higher parities. This is because in the case of South Korea was the only way to really obtain, recover this big steep increase of the sex ratios at birth. And the last one is that here we're using the total fertility rates from the previous step. But these total fertility rates are from the observed, from the model. And this is what I told at the beginning, that at some point we are trying to in agent-based modeling, what we try is to have some interaction among individuals and check what's happening at the macro level. But here we have some feedback of the macro level in the individual, because the decision of aborting of an individual will depend on the total fertility rate in the model. So the result at the macro level has an effect at the macro level on the decision of the individual in the following step. Yeah. Okay, so now, this is just a summary of the parameters that we have. So we have 6 parameters, the model basically, 2 for the readiness, beta and sigma, some preference, this for the some preference intensity, the increase of the some preference, this is the decrease once the some preference has been realized, and these 2 parameters that determine the technology diffusion. Okay. So now let's forget the math and all this, and let's go to the graphs and the results. Results. I will show you results of India and South Korea and India. So here is South Korea. What are we showing here? So we have 2 lines. The continuous lines, okay, are the total fertility rates. And the dotted lines are the sex ratios at birth. Gray lines are the UN estimates, from the world population prospects. And the colored ones are our estimates. What we observe here? First, that our model is able to recover the total fertility rate. So because you see, this gray line, maybe you don't see very well, but it overlaps with the red line. So we are able to recover the total fertility rate estimated by the United Nations. Regarding the sex ratios at birth, here we have the gray line that are the UN estimates, and these blue lines are 2 scenarios. The first scenario, the dark blue, has a beta equal to 0.2. What does it mean? The parameter beta is the one that determines the probability of abortion at parity 0, the probability of abortion before even having a child. And what we observe is that the best way to reproduce the South Korean steep increase of the sex ratios at birth in the 80s is by accepting that couples were practicing sex-selective abortion even before having the first child. That means that if they were having the first child, they knew, there were some cases they knew they was a girl, but they still wanted to have a son, so they aborted in the first time, which is quite surprising. And because if we have a beta equals 0, I'm saying that there's no abortion at the first parity, then we are not able to recover this steep increase of the sex ratios at birth. The case of India is a totally different scenario. First is that we are starting with a higher fertility rate. Look at in the previous one, here we are at 2.4. Here we are starting at same year at 4.5. So we have in a context of a much higher fertility. We are also able to reproduce the total fertility estimates of the United Nations, and these sex ratios at birth are delayed, so we don't have this steep increase in the 80s, and less peaked. Yeah? And here we just show 2 lines, but are with different values of the model parameters, but with very little differences. This plot here, what I'm showing is the same as the previous, very similar to the previous one of South Korea, but there are 2 important things. One is that when we have an agent-based model, we run the model thousands of times. So we have lots of estimates, and out of these estimates, we can compute empirical confidence intervals. And this is what we are showing with this gray area here, around the sex ratio at birth. So this gray area here is showing us the 95% confidence interval of our estimates. empirical confidence intervals because are obtained from the data simulation. And the second idea that from here is that what I said earlier is what is the effect of the abortion in the fertilities. So what we have is that we have two scenarios. The light gray is that there is sex-selective abortion, and the dark and the black line is that without sex-selective abortion. And these dotted lines are the UN estimates. And what we observe is that if there's no sex-selective abortion, so couples are not practicing abortion, then the total fertility rate will have been higher. And whereas if we accept that there is sex-selective abortion, this light gray, we can best recover the trends estimated by the United Nations. Okay. Now here you can see are these three elements that I mentioned: this ready, willing, access to some preference, access to technology, and probability of abort. This is how we model it. Here we have these red points are some estimates obtained from surveys, health surveys, and this is how we attribute some preference at each year for the South Korea. The access to technology, what we observe is that this steep increase of the sex ratio at birth has a strong effect on this. That means the access to technology was very low in the 80s, but in the mid-90s, almost all Korean population had access to technology to practice, to determine the sex of the fetus and decide or not to practice abortions. And finally, this readiness to abort is the probability to abort for different parities. At parity 0, that means before having the first child, this is the values here. At parity 1, that means individuals have a girl, and then they're having the second child. Are they going to abort? Well, the probabilities are already high here in 1980, and in a few years they go to 100%. And at parity 2, that means that couples have two girls, they're having the third child, and they find out that it's a girl. Then the probability of having an abortion is 1. In the case, this is for South Korea. In the case of India, again, it's total different scenario. We start with higher some preference that is declining smoother. Regarding the access to technology, we don't have this steep increase, so it's delayed and lower. And finally, the readiness to abort, again, is higher. The probability to abort is really low at parity 0. So before having the first child, the probability to abort is almost 0. Then at higher parities, this probability increases. But it never reaches, like here, this probability of 1. It has not been observed, as we are here, only when we do our projections up to 2050. Okay, so now, last two slides of results. What I would like to mention is this idea of the counterfactual scenarios that I mentioned at the beginning. No? The advantage of agent-based modeling, that we can play with the model, we can try to find out what if scenarios, what would have happened if something, or we change this or we change the other thing. So what we observe here is that if some preference were constant, meaning that the whole population want to have at least one son, then the sex ratios at birth of South Korea will have increased up to 145 and stabilized at this level. This is a totally, and it is not real. This didn't happen, and it's very likely that this will happen. But can give you an idea of what will happen if all individuals had some preference. If the some preference had remained constant at the 1980 level, so this remain constant 1980 levels is like about 6%, 60% of individuals having some preference, then we will have been in this scenario. A steep increase, and then the sex ratio at birth will have remained at around 119, 20 for the subsequent years. Whereas if we accept that some preference declined over the years, then we can better recover what the observed trends. A steep increase in the 90s and then a decline in the following years. And finally, the last slide of the results is the sensitivity analysis. Something very important in agent-based modeling is that one needs to carry out a sensitivity analysis to evaluate which is the effect of modifying one parameter in the outcome of the parameter, of the model. Because, I mean, one can build a model and say, okay, I have 30 parameters and I'm able to reproduce this. And they say, okay, and if I change this parameter, the second and the third, and another combination of values, I can maybe get the same result. So one needs to evaluate, quantify which is the importance of the parameters. And to do this, what we did is we measured the model fit with the root mean square error. So this is comparing the sex ratios at birth of the UN with the ones we obtained in our simulation by modifying our model parameters. So in this panel here, we have all parameters fixed except the ability parameters. Ability parameters are the access to technology, this technology diffusion. And by varying these parameters, we obtain this dark area here is the combination of values of the parameter that offers a lower value of the root mean square error. That means that the model fit is best. And here in the right panel, we do the same, but for the readiness parameters. So that means this is what changing, so having all parameters fixed except sigma and beta, that are the parameters that determine the probability of abortion. And we obtain that the combination of parameters that best reproduces the UN trajectories are these areas here. So these plots can show us which values of the parameters are more offer a best fit and how sensitive is the model to changing one of these parameters and get far away from these black areas that offer the best fit. Okay, so now conclusions. Regarding the model, what we have is that what we observe, the results of the model shows that the SRB distortions can occur even in a context of declining some preference. So even if there is some preference declining, as I show with these counterfactual scenarios, we still have a distortion in the sex ratios at birth. The sensitivity analysis suggests that there is a key role of the technology diffusion. So technology diffusion has a strong effect on this steep increase in South Korea that is not observed in India. Important fact that I already mentioned, that in South Korea, the readiness to abort before transition to first birth, so couples with strong, so couples were deciding to abort even when they were childless. In the case of India, we have less peaked sex ratio trajectories in a slower technology diffusion, but we are also in a context of a higher fertility. And finally, these are the results regarding the model. Of course, this model has some limitations. I would say that the biggest limitation is that it's a relatively simple model, that we are not accounting for heterogeneity, so we are not distinguishing between social status, socioeconomic status, or regions. However, the advantage of being simple is that it can be easily reproducible in other contexts, and also connects a little bit with the idea that I said earlier, that ABM should be used to add intuition. Maybe we don't have as precise idea of socioeconomic status or in sex ratios at birth, or the practice of abortions, but we can have an idea of what is going on. And now, finally, I would like to connect with what I said at the beginning about agent-based modeling. Of course, agent-based modeling has some criticism. And the main criticism that agent-based modeling has is that the ability, as I said, the ability to reproduce an empirical pattern is not enough to provide the validity of a model. as I said, if you have 30 parameters, you reproduce an empirical pattern. How is it that if I change these parameters, I also get the same result? This is why some people say that, okay, but agent-based modeling at the end, there's a risk of just becoming a good story. But is it realistic or not? To address this criticism, I believe there are two main solutions that have been suggested. One is the use of these meta models to quantify the sensitivity of the outputs to different parameters. This is what I showed you with the sensitivity analysis. So this provide really a quantification of how sensitive is the model to changes in the input parameters. And the second one is to have some standard procedure or a model description to facilitate the reimplementation of the model. Sometimes agent-based modeling become like a black box that people have a model, have a code, run and say, oh, this works. Okay, but if one wants to make a model useful to the scientific community, if you want to make that people believe that this is useful, it's very important that we document the model, we provide the code, we make it available so everyone can use it, can analyze it, and can extend it if interested. And I believe that if these two issues are met, it's probable that the ABM will become like a standard tool for demographers in the near future. So thanks very much.